Today we're going to talk about molecules. This is part of a discussion about compounds. First we're going to look at things that are bonded covalently. We call these molecules. We'll find out what bonding covalently really means later on. And then later on we're going to look at a whole different class of compounds called ionic compounds that bond a completely different way. This is just a brief overview today. You're going to learn how to name them and how to recognize them. That's basically it today. So what is a molecule? A molecule is a combination of a specific number of atoms that are held together in a fixed arrangement. That's the key. A specified number of atoms of a certain kind, and their pattern of space is always the same. The thing that holds a compound together, that makes a compound not just an element or just a mixture of elements, is that there's a chemical bond between the atoms in this compound. In molecules, we're seeing covalent bonding take place. We'll learn more about how this works before, but the basic idea here is that they're electron-sharing bonds. Electrons are shared between atoms, and that's what holds them together. When that happens, it results in molecular compounds. Covalent bonding happens when nonmetals bond to other nonmetals. So remember, the nonmetals are the things over on the right-hand side of the periodic table, and also including hydrogen. When those things bond to one another, you're going to see covalent bonding take place and a molecular compound will form. Ionic bonding, on the other hand, is electron exchanging bonds. Instead of sharing the electrons, they're going to actually, one atom will give its electrons to the other atom, and that turns out to be advantageous, and it results in salts, or what we call ionic compounds. This typically happens when nonmetals make bonds with metals. So if we have bonding from an element over here with an element over here, here to there, that kind of bonding, that's what we call ionic bonding. Now, here you're going to see a feature that will often show up in these notes. It's called working it out. When you see working it out at the top of the screen, what that's typically going to mean is you should stop the video and you should try and answer the question here. I'll go on to answer it after that, but you should try and see if you can figure it out on your own first. Take a look at your periodic table and ask yourself, is Na2O a molecular compound or an ionic compound? Well, here's the answer. Sodium is on the left-hand side of the periodic table. It's a metal. And oxygen is a nonmetal. When metals and nonmetals combine, that's an ionic compound. So the correct answer is it's an ionic compound. Next question. Is CBr4 a molecular compound or ionic compound? Here's the answer. Carbon is a nonmetal. Bromine is also a nonmetal. So because this is a nonmetal bonding with a nonmetal, this is a molecular compound. Water, H2O, is this molecular or ionic? Here's the answer. Hydrogen is a nonmetal. Oxygen is also a nonmetal. So that would make this a molecular. Is NaI a molecular compound or an ionic compound? Na is sodium. Sodium is a metal. Iodine, I, is a non-metal. Because it's metal to non-metal, this is an ionic compound. Is H2SO4 a molecular compound or an ionic compound? Well, this is more complicated than the others, but hydrogen is a non-metal. Sulfur is a non-metal. Oxygen is a non-metal. Since all three are non-metals, this compound is a molecular compound. One last example. Is CuSO4 a molecular compound or an ionic compound? Well, copper is a metal. Sulfur is a non-metal. Oxygen is a non-metal. Since we've got a metal involved with non-metals, this is an ionic compound. So when you have more than two species involved, as long as one of them is a metal, chances are really, really, really good that it's an ionic compound. The last thing that we're going to look at today is naming molecular compounds. How do we give these things names so we can talk about them intelligently? There are two kinds of names for molecular compounds. One are called trivial names. Trivial names are shorthand names for substances. They're sort of like nicknames. They make it easy to talk about them when their names are complicated. Most of the time we're going to avoid these, but they do have a useful purpose, particularly when you're talking about complicated substances, like drugs, for example. Look at this name. 2,4-methyl propyl phenyl propanoic acid. That big long name is what we call ibuprofen. So that nickname is very useful because nobody wants to say 2,4,2-methyl propyl phenyl propanoic acid all the time, every time they want to take that Advil. Systematic names, however, are the kinds we're going to mostly rely on. There are two trivial names that we'll use pretty often. One of the trivial names that we'll use is water. Of course, everybody knows that water is H2O. The other trivial name that we'll use is not as common, ammonia. Ammonia is NH3. Other than those, we're probably going to use systematic names almost all the time. Systematic names have to specify two things. They have to specify which types of atoms are there, in other words, what elements do you see in the compound, and how many of each are there. And then as the molecules get more complicated, there's another thing that has to be shown, and that is something about the shape. The name has to give us some indication of the shape. And that's where that complicated name for ibuprofen came from. A lot of those terms were indicating shape. So here are our naming rules for binary compounds. Now, here's what a binary compound is. Binary compound means there's only two elements in the compound. If it gets more complicated than that, then we have to rely on a different kind of a name. And first rule, the element in the group to the left in the periodic table is listed first in the name. So the farther to the left in the periodic table, the closer to the beginning of the name. If there are two elements that happen to be in the same group, then the one that's in the lower period is listed first in the name. Third rule, the first element listed in the name has the ordinary name of the element, the same name that it always has. Like if it was nitrogen, we just say nitrogen. If it was oxygen, we just say oxygen. The next rule, the second element ends with the suffix "ide." So, for example, oxygen, if oxygen was the second element listed, we would call it oxide. If nitrogen was the second element listed in the name, we would call it nitride. And the last thing is we specify how many atoms of each element are in the molecule. We do this using a specific set of numerical prefixes, these word parts that mean numbers. Here's what they are. One atom of an element, we give it the suffix or the prefix mono. Now, there's a disclaimer here. Mono, this is used with oxygen only. And realistically, practically, almost nothing ever gets mono except oxygen. And it's usually only when the oxygen is the second element listed. So mono is used sparingly. 2, di. 3, tri. 4, tetra. 5, penta. 6, hexa, like a hexagon. 7, hepta. 8, octa, like an octopus. 9, nona, or just gnome. And 10, deca, like a decade. So by placing these prefixes before the name of an element, we indicate how many of that element is in the compound. Okay, here are some examples. So this is working it out again. I'm going to stop the video and try it, and then look at my answer later. First question, what is the name of CI4? Well, here's the answer. Carbon has no subscript here. That indicates that it's just 1. So I'm just going to write carbon. Even though mono is the prefix for 1, when it's not oxygen and it's not the second element listed, we don't use that prefix. The subscript on iodine is 4, which means there would be 4 of them. So I'm going to start with tetra, and then I'm going to end with iodide, because iodine is the second thing listed. Carbon tetraiodide. What's the name of NO2? Here's your answer. Nitrogen has a subscript of 1 implied there, so I just write nitrogen. Oxygen has a 2 subscript. The prefix for 2 is di, so I write dioxide. What's the name of N2O4? Well, nitrogen has a subscript of 2. The prefix for 2 is di, so I write dinitrogen. I don't change the ending if it's the first thing listed. Oxygen has a subscript of 4, so I write tetrahydrogen. oxide, dinitrogen tetroxide. Now chemists will often skip one of the vowels. If two vowels show up in the middle, they kind of make it awkward to say. They'll drop one of them. So most chemists would say dinitrogen tetroxide. They would shorten it a little bit. What's the name of SF6? Sulfur has a subscript of 1 implied there, so we just write sulfur. And fluorine has a subscript of 6. The prefix for 6 is hexa, so I'd write sulfur, hexafluoride. One more. Now this is, we're usually going to use the trivial name for water, but let's try to name it scientific. Here you go. Subscript for hydrogen is 2, so we'd write dihydrogen, and the subscript on oxygen is 1. Now here oxygen is the second thing listed, and its subscript is 1. So here's where we would use that mono prefix, monooxide. And once again, here's a situation where one of the vowels will get dropped, and most chemists will write dihydrogen monoxide. So next time you want to drink of water, ask for dihydrogen monoxide, and then everyone will know that you're a nerd. See you later.